All right. So we're going to talk about what? Half angles? And you have to have kind of a book to get these half angle identities, or off of a sheet of paper or something like that. They're on the paper. But if you look really closely at them, let's look at the cosine. And whatever the angle is, let's say we want a half angle of 80 degrees, okay? Then that would be, A would be 80, and then we divide it in two to get a 40-degree angle. Plus or minus, depending on what quadrant it ends up in, square root of 1 plus the cosine of A over 2. But if you notice the sign, it's very similar. It's plus or minus the square root of 1 minus the cosine of A over 2. So there's if you're looking for the cosine, you have to have a plus sign there. If you're looking for the sine, you have a minus. So we do need to know what the cosine of our function was. Now the tangent, there's a lot of different variations on the tangent. You know, the tangent, I'll write it down, the tangent of A over 2 is, you probably wouldn't want to use this one too much, you know, because you could write this as two separate or one big one. That one looks a little hard to use because you got this big old radical. It might be easier to use this one if you do the sine of A and the cosine. That'd probably be a little bit easier to use, huh? Or they have a variation on it. 1 minus cosine A over sine A, like that. That one might be a little bit easier to use than this one up here. But it just depends on, this would be good if you only knew the cosine. You want to figure out the sine. See, these are on terms of cosine. So we'll try one and just see what we can do with it. Okay, this is on page I'm going to do example 1. It's on page 234. EX1, example 1. Okay, so here we want to find a cosine of 15 degrees, right? Well, personally, if I had to find a cosine of 15 degrees, I would not use a half angle formula. I would use the expanded, difference of cosine and expansion. Like I would use cosine 45 minus 30. That's how I would do it. And that would give you the cosine of 15, right? And then that would be cosine 45, cosine, plus sine. I think that's a lot easier than using, because we know the cosine of 45 is the square root of 2 over 2, cosine of 30, radical 3 over 2, sine 45, radical 2 over 2, sine 30, 1/2, and you can get those off your charts. And then you'd leave it as radical 6 over 2 plus radical 2 over 2, or the whole thing could be over, 4. Or it could be radical 6 plus radical 2 over 4. Personally, I think that's a lot easier, But let's use this half angle and see what happens. And then we'll compare these two results. So I want to find the cosine of 15 degrees. So the cosine of 15 degrees is the cosine of 30 divided by 2. So in our formula, A is going to be 30. Okay, that's what we're going to use. And we're going to use this formula. Where's the formula here? Just had it a second ago, now I lost it. I'm going to use this formula right here. Cosine of A over 2, which is 30 over 2, is equal to plus or minus square root of 1 plus the cosine of A divided by 2. And this whole thing's under the radical. So let's plug into that. We're going to put a 30 here. So this is the square root of 1 plus the cosine of 30 over 2, like that. Okay, so what's the cosine of 30? This is just our formula here. Okay, so this is the square root of, I'm going to write this, 1 plus the square root of 30 is radical 3 over 2. And that whole thing is over 2, like that. So that's pretty messy, huh? So what the book suggested you do is you distribute a 2 to both of these terms. Like you take this term, you do this in inks, a different color, so you can kind of see. We're going to multiply this whole top by 2 and then the bottom by 2. And the reason they're using that is because you have a 2 on the bottom right here. So that would give me the square root of, I'm just going to scoot it over here. Let's scoot this up. This will give me the square root of 2 times 1 is 2 plus this 2 will cancel out this 2. So it's 2 radical 3 over 2, which is just radical 3. And then this, so that gets rid of the fraction up here on this part. And then that gives me 4. So I'm going to write it over here. And that's what they said the cosine of 15 equals. It equals, so let's bring this all the way down, 2 plus the square root of 3 over 4. Well, we can take the square root of 4, huh? So this would be cosine of 15 equals the square root of 2 plus the square root of 3 over 2. So that's what they're saying that this cosine equals. Okay. Well, does that look anything like this? Do these look the same? This is the cosine of 15. So are we wrong? Well, what I did is, because these really look totally different, don't they? And it doesn't look like it's very easy to transform this into here or this form into here, huh? So what I did is I actually calculated this out on my calculator. I went into the calculator, put the square root of 6 plus the square root of 2, and then I divided it by 4. And I came up with 0.9659. And then what I did is I put this one in, I took the square root of 2 plus, and then I entered in the square root of 3, and I divided by 2, and I came up with 0.9659. So they are both exactly the same, they just don't look the same. But if you were to convert this to a decimal, the cosine of 15 equals that, and we could look on our calculator, and we can hit the cosine of 15, which obviously would be the easiest way to do it but they wanted an exact answer. But if we didn't want an exact answer, if we just hit the cosine of 15, hit equal, you see, what do we come up with? 0.9659, which is exactly what we got by doing it either way. So I would think the double angle is a little bit easier, cosine, cosine, sine, sine. But, this will also work, but it's probably one that we don't use quite as often because, first of all, the form is kind of a little messy. We got a square root and then we got a square root under a square root, But it does give you the correct answer, and this gives you the correct answer. On the quiz, we want to do them by this method because they want you to get a little experience with that. But in reality, if we weren't looking for an exact answer, we'd probably just plain out use our calculator, and come out with just as accurate. This is obviously the most accurate answer, both of these. But, so sometimes an answer could be correct, but look like it's in a totally different form, huh? And I suppose there's a way we could mess around with this and get it to look like this or vice versa. But we don't want to do all that work. So this is the way it works. We simply just think of a number that we could divide by 2 to give us 15, which is 30, or double that number right there. And then choose the correct formula. We wrote down several formulas here. And the cosine one has to have the plus sign. Okay, so we want to make sure we write down the correct formula. And if you didn't get these formulas, you could always kind of just look at the tape and pause it and then write them down. If you don't have a book or something, you could pause the video and just write these down. And then it's just a matter of, let's not look at that one, let's look at this. It's just a matter of substituting into this and placing this A right here in the formula with the 30, not with the 15, with the 30. And then, of course, the cosine of 30, you can use your unit circle or whatever and get the cosine of 30. And then we just use this 2 to kind of, but you have to distribute the 2 to the 1 and then the 2. This is really 2 plus 2 radical 3 over 2, like that. That's what you're getting on the top over 4. See, so these 2's are going to cancel off, and that's where we get the 2 plus radical 3 over 2 times 2 is 4, and the square root of 4 is 2. Okay, so that's kind of the idea behind it. Okay, let's look at example 2. I got to work this one out. I don't know what I did with it, but okay. So let's look at example 3. Okay, let's do that one instead. Here we have the cosine of S is equal to 2/3. And they told us that the boundary that S is going to fall into is between 3 pi over 2 and S, which is 2 pi and 2 pi. So 3 pi over 2 would be 270 and 2 pi is 360. So it looks like this is in the 4th quadrant, is what they're talking about, that we're in the 4th quadrant. And that makes sense because the cosine should be positive in the 4th quadrant. Okay. And I'm not going to do all of them. I'm just going to try to find, because on your test, it's asking for the cosine. Okay, you have a problem that's similar to this, and he asks for the cosine of S over 2. So we just do the cosine part, okay? We won't worry about the cosine, the sine. So what they did is they kind of looked at this angle right here in 2/3, 2 over 3 cosine of S. And maybe I could draw this. Where can I draw this? So let's draw it over here. And so they're looking at an angle, this angle right here, S, is right here. somewhere in this, well, we went out here. What is the cosine? It's the adjacent over the hypotenuse. So they went out here 2 units, and this is 3 units. So somewhere down here was our point. So we were in the 4th quadrant. But now we want to take, so this was the angle we were looking at, this angle right here. But now they want to take half of this angle. So if we were to take this angle right here and cut it in half, it probably would end up in the 2nd quadrant. Not exactly parallel to that, but you know, maybe this is a little steeper, but it's probably going to end up in the 2nd quadrant. So when we find S, S over 2, the half angle of this, it's going to be in the 2nd quadrant, which means it's going to come out negative. So we know our answer is going to come out negative. And that's all they were trying to figure out is what sign are we going to get? So we'll probably get a negative answer to this problem. Okay, so now it's, what they're going to do is they're going to take a look at the little formula, and they're going to put it into our formula. The cosine of S over 2 is equal to what? It's equal to 1 plus the cosine of S, this 2/3. And this whole thing, excuse me, is divided by 2. Okay? I had this worked out. I had this worked out on a sheet of paper, but I don't know what the sheet of paper. Let's see. Well, anyhow, we could either add this up, or you can multiply everything by 3 like we did before. The only problem with doing that, well, we could try it. Let's see what happens. Let's try like we did before. Let's multiply this by 3. And so we get 3 plus 3 times 2 is 6 over 3, right? Over, and we have to multiply the bottom by 3, that would be 6. And we want, remember that when we take a square root, this is going to be plus or minus. But we already determined that we want a negative value. So that's what we were kind of fooling around over here, trying to figure out, you know, that this probably would end up in the 2nd quadrant. We were in the 4th, half of that would probably be in the 2nd. Okay, so then let's see what we got. We got 3 plus 2 over 6, square root of that. So this looks like it's the square root negative square root of 5 over 6. And then they probably rationalize this, multiplying this by 6 on the top and 6 on the bottom. So they ended up with negative square root of 30 over the whole number 36. Square root of 36 is 6. So that's where they ended up with it. And that's what you want to do in your quiz. You don't have to find all the angles. We just want to find the cosine of S over 2, the half angle of that. And that's what it would be. So the regular angle was, this was theta, or whatever you want to call it, A. And half of A or half of S is this mess. Okay. Let me see if I have another problem here. Let me do one more problem here. Sorry about that. This was the one I wanted to do. So I'm going to give you a kind of a freebie. On your quiz, you have this problem. I'm actually going to give you one problem off the quiz. They have a problem like this on your quiz. And the directions are use the identity to write each expression as a single trig function. So we know the formula for cosine of a over 2 is equal to the square root of 1 plus the cosine of a divided by, what is it, 2. We have that formula. So this is really saying this is the cosine of a over 2. And they're saying this 34 is a. So this is really the cosine of 34 over 2. So this is really the cosine of 17 degrees. And that's all there is to that problem. So they're saying this is really right here is A. This is your A. See? So this is really A over 2, 34 over 2, cosine 17. And that's all they want you to do on those. So they're fairly easy. Now remember, if it has a minus here, it isn't going to be cosine, it's going to be sine of A over 2. Just that easy. So this quiz, it looks kind of difficult when you first look at it. And maybe the first 4 might be a little hard, but then you see the rest of them are not too difficult. Okay, so that's kind of the idea behind it. I'm not going to spend a lot of time on this. I'll let you kind of figure it out a little bit on your own too.